All right, so we're going to look at this circuit, which we looked at previously. When we said what I want to find here is I of t. So I have v of t equal to Vm cosine omega t equal to Vr plus Vl, which we say is IR plus L di dt. So that whole thing, we said previously, I guessed that the current is I of t equal to I cosine omega t plus phi. So what this means is if I look at time, right, and this is the voltage V of t, means that my current would look probably something like this. In other words, same frequency, but there is some phase shift phi between the two. Okay, that's this angle right here. And so we said, well, there's a way to do that to say, well, this is also equal to A1 cosine omega t plus A2 sine omega t. And I can break this guy up with trig identities and figure out that I cosine phi cosine omega t minus I sine phi sine omega t. I could take this, and I know that this now has to be A2. This needs to be A1. I plug this guy into the differential equation, solve for A1 and A2, and then I can solve for I and phi. And that's messy and ugly, and we don't want to do it, right? So what we had talked about in class the other day is I said, well, if I make this V of t, and I say V of t is Vm cosine omega t, well, I know that that's also the real part of Vm e to the j omega t. Again, you can see that if you expand e to the j theta equal to cosine of theta plus j sine of theta. Okay, like that. So, all right, so if what I do, we said in class, is I said, well, I view the circuit instead as saying, let's say I've got Vm e to the j omega t. I have R, I have L, and I solve for the current here, right? And what we said, what we ended up with is, and when I do it that way, I say I have V e to the j omega t equal to R I plus L di dt. And I guess that my steady state current is going to have a form real of I e to the j omega t plus phi, right? Which if I expanded that would be I cosine omega t plus phi, like that, okay? So I rewrote this and I said I can call this I e to the j phi times e, let me clean that up for a second, okay, e to the j omega t, like that. This thing again we call our phasor, I underscore. So it's the real part of I e to the j omega t, like that, okay? So if I plug this into the equation, I say, well, V e to the j omega t equals R times I e to the j omega t. Oops, let me make my brackets equivalent. Okay. All right. Plus L times d by dt of I e to the j omega t, like that. Okay? I take the derivative there and I get r I e to the j omega t plus j omega L I e to the j omega t. Right? So the j omega came down. So now I say, well, I've got e to the j omega t everywhere. Boom. So now I have my phasor relationship. R I time to grade your exams. J omega L I, like that. Now, my goal here, this is the thing to keep in mind. My goal was to figure out the amplitude, which is essentially the magnitude of I, and the phase, which is the angle of I, right? The angle of I. In other words, I want to figure out if I have I equal to E, I wrote it like this, I e to the j phi. I want to find this, and I want to find that. Okay? That's basically our process. So there's two equations in here, and that's what I want to do. So I want to look at the magnitude, which becomes ultimately the amplitude of my cosine wave, or I want to look at the phase angle. Okay? So if I do that, I take the magnitude of both sides, I plus j omega L I, like that, right? This guy is just V, right? Because so our input was V cosine omega t, and that was the real part of V e to the j omega t. So this guy, the phasor, just to be clear, the phasor is V e to the j 0 degrees. Okay, so this guy is just V. Then I write this and I say, well, that's the magnitude of R plus j omega L times I, the phasor. That's going to be equal to the magnitude of R plus j omega L times the magnitude of I, like that. So then I say, well, okay, the magnitude of I has to be equal to V divided by the magnitude of R plus j omega L, right? So if I write that out, if I have a complex number a plus jb, and I take its magnitude, that is always the square root of a squared plus b squared. So I write this as r squared plus omega squared L squared with the v there. So now I've got my amplitude term. Okay, like that. So this is my magnitude. To be careful about that. It's the magnitude of it. To get the angle, right, I go back to my original equation, right? So I had that v equals r plus j omega L times I. Okay? So essentially now what I have is I have two complex numbers, a, b, multiplying each other, and I'm going to take the angle of those. The angle of the product is equal to the angle of a minus or plus the angle of b. Okay? So in this case, if I take the angle of both sides, all right, the angle of v, well, remember back to here, the v, the phasor, is just has 0 degrees angle. Okay, so the angle here is 0 degrees. The angle of r plus j omega L, so I'd say, let me just write this way, angle of r plus j omega L plus the angle of I. So I get that the angle of I has to be negative angle r plus j omega L. Okay, so the angle of r plus j omega L, if I get that, I get that minus arctan of imaginary over the real part. Okay, like that. And so have now found this guy was my phi. All right, so again, back to what was our goal. Our goal was to figure out the amplitude and the phase for my phasor. This was the amplitude piece. This is my phase piece. So now I know that I, the phasor, is equal to V over square root R squared plus omega squared L squared times e to the j negative tan inverse omega L over R. There we have it. Okay? And so my I steady state now is the real part of I e to the j omega t, and I take it back. This is from my inverse phasor relationship, so it's the real part of V R squared over omega squared L squared, like that. E to the j omega t minus arctan of omega L over R, like that. I take the real part of that, it's going to be the cosine term, right? So V over R squared plus omega squared L squared cosine omega t minus arctan inverse of omega L over R, like that. This is the same answer that we got previously. All right. Instead of using trig identities here, we basically made use of the complex numbers. Okay. So hopefully that helps a little bit to understand how all this stuff kind of comes together, and hopefully that'll help a little bit with the homework going forward.